can talk about typical deployment topologies and what the implications are. And I can just answer any questions you guys have in terms of the implications in terms of policy. Was that useful if we take that approach?
Yeah.
So sounds good to me.
Excellent. All right. So jumping right ahead. So the broad, actually, I'll give a little bit of context on the problem we're trying to solve with both SPIFFE and then also SPIRE, which is establishing trust between systems in really heterogeneous environments. So you're going beyond the scope of, say, a single Kubernetes cluster or what might be available to, say, Amazon, for example, and so recognizing that for a lot of folks, they're running in environments that might be a mix of both, different cloud providers, let's say, different different vendors of hardware, but then also lay it on top of that different middleware. I'm just going to use the word middleware providers, but by that I mean things like container orchestrators like Kubernetes, PaaS systems, which I guess are also container orchestrators to a certain extent, like Cloud Foundry, even things you classically might call a piece of application middleware like, say, Tomcat or JBoss. So the idea is that because you have all of these different forms of complexity, you there and different interacting systems, you therefore have a pretty heterogeneous idea of what a workload identity looks like as well. It becomes kind of fragmented. And so, traditionally, several different ways of doing that. Model 0 is really just allow the network to figure out workload identity. So in other words, if I can make a network connection to something, then I assume that I am authenticated and authorized to do so, which becomes pretty difficult, particularly, it's both very brittle, but also pretty cumbersome in, these kind of heterogeneous deployments. The second model is to, is basically, use a shared secret to authenticate something, and then based on that authentication, authorize them. And that's a model that, works reasonably well, except that you now have the problem of secret distribution. You typically have, unless you're using something like, Kerberos or OAuth, you also have the problem of, identity being distributed across multiple, every different system having different ideas of what a workload identity actually is. And then the other model is what, for want of a better term, we've just called platform-mediated identity. And this is the model that you often see across any kind of common platform, like a container orchestrator or an infrastructure provider or a PaaS system. And the broad idea here is that because there is an orchestration layer of some kind, which has some context for your workload and its identity, it's able to actually offer up a privileged API that your workload can use to retrieve its identity a priori, and then use that to establish trust to some other system. So an example of this, right, might be in Amazon. If you're running in an EC2 instance, there's an EC2 instance metadata API that you can call, and you can get a workload can call that and retrieve a document that will prove the identity of the instance that it's running on, and then that can also be used to retrieve other metadata about provable attributes of other provable attributes about that workload, to say the security group that instance is running in, and so forth. You can also get things like STS tokens, for example, that you can use to STS tokens bound to Amazon IAM roles. And again, the workload, in order to retrieve these, doesn't ever need to authenticate to Amazon. It just calls Amazon, and because Amazon has the context of the callee, it can figure out if it's actually entitled to any identities inside Amazon, and if it is, which ones it's entitled to. So there's this general idea of a privileged API, and likewise, if you want to verify a document from one of these documents, if I'm a remote workload that wants to authenticate a source workload, then I have mechanisms to be able to do that as well. And this model actually works really well. It's nice in that it involves a lot of the challenges of kind of classical secrets management. I have to create an identity and then distribute key material and then rotate that key material and do that securely. I don't need to do that in this model because I have this privileged API that effectively takes care of that for me. It also means I don't need any sort of pre-established identity for my workload in order to represent myself to all these different systems. The big weakness with that model, though, of course, is it only works if everything's running on the same platform. So to take the Amazon case, it only really makes sense for me to do this if all of my source workloads are all running on Amazon. And not only that, but Amazon actually is able to reason about those workloads as well, which can be difficult if, for instance, I'm running, say, a Kubernetes cluster on a set of EC2. I'm running a self-managed Kubernetes cluster on top of a set of EC2 instances. And in that case, I might have, Amazon might understand that a workload is calling out to an EC2 instance, but it doesn't necessarily know, which workload inside that cluster it's talking to. So there's plenty of cases where this model actually in practice starts to break down. So the very high level, I guess, the goal of the SPIFFE project is to define, both a set of standards and then also an actual implementation that allows me to have, this sort of same convenience of having a privileged API that just can figure out of band who the workload is, and then to be able to deliver it a credential, a short-lived credential that actually asserts that identity. And then also to be able to provide, via a similar mechanism, if I'm another workload, a mechanism to verify the identity of another party. So yeah, before I go on, does that broadly make sense? I'm a little sleep deprived, I apologize. So I mumbled a bit, but
yeah.
Yep, makes sense to me.
Cool. We're trying to basically have our kind of cake and eat it too, as far as the advantages of this model. So the way we've gone about that is we've actually broken this out into two projects, and there's all sorts of reasons behind why we did this. But broadly, when we talk about SPIFFE, SPIFFE's both a bit of an umbrella term, but it also refers to a specific set of I won't call them standards because they're not ITEF yet, but specifications for how other workloads should interact with this system. And there's a few components of that. We talk about the format of the identities, the format of the documents that they can retrieve via these privileged APIs, and we call them SVIDs. And then we also have this standard API that can actually be used to retrieve the identity in the first place and also to validate it. We call it the workload API. There's actually, this deck was put together around about the beginning of the year, and so the beginning of last year, and so there's some additional components of this specification now, notably a thing called federation, which allows multiple different issuers of SPIFFE identities to be able to peer and mutually trust each other. But that's a little out of scope for this deck and probably this conversation. But SPIFFE defines basically the set of specifications, and so the idea is that there will maybe many different systems that implement these specifications over time, and there's actually a couple already. So the Istio project out of Google implements part of this specification, the SVID spec and the SPIFFE ID spec. HashiCorp has a product called Console that implements some of this as well, and we're starting to see some other tools like CyberArk, for example, are starting to implement bits of this as well. And we're actually starting to get tighter as a project on exactly what constitutes SPIFFE compatibility, so that there's not just a set of specifications, but a minimum, a sort of meaningful guarantee to a developer as to whether or not something is quote unquote SPIFFE compliant and SPIFFE interoperable. But it's a set of specifications. That's really all it is. And if you want actual running software that implements those specifications, then for that, again, as I say, there's many different vendors, but the one that comes with the project is called Spire. Both of these, by the way, are they're both under the CNCF. They're both Apache 2 licensed and thus independently governed. And Spire actually is beyond it's more than a reference implementation, which is what it started out as. It's now actually a very extensible and pluggable piece of software. But broadly, the way to think about it is Spire implements SPIFFE and gives you SPIFFE. It's designed again for very quite heterogeneous environments. So where I might have some workloads running, I might have multiple Kubernetes clusters, I might have a couple of different cloud providers, and I need a contiguous model of identity for all of them. So the components, so firstly, just to break down the kind of components of the specification, the first is the SPIFFE ID, which is really just a string, and as you can tell, it's basically a URI. The two sort of main components of that are what we call the trust domain, and then the rest of it being the workload identifier itself. When we get into the mechanics of how SPIFFE works, or rather how Spire works, is it's effectively a certificate authority with a bunch of metadata and a bunch of APIs and tooling around So every installation of Spire and of most SPIFFE implementations is effectively anchored on a single root of trust. And concretely, when you start start Spire, you need to seed it with an intermediate a signing key of some kind. So a trust domain is bound to a signing key, and if we get into federation, then there are ways where different trust domains can still workloads running in different trust domains can still establish trust to each other. But basically, what I'm saying is, if I have multiple different workloads, all with different identifiers, but with a common trust domain, then ultimately the identity of these things is all backed by the same signing key. And this becomes useful in a few different contexts, actually, but generally where you have different degrees of trust in your infrastructure. So, for example, if I have development versus production versus staging, I may well create different trust domains for those because my production infrastructure is locked down, it's audited. I know that the signing keys for these things are very, very closely scrutinized and heavily monitored. Whereas in my staging environment, I don't necessarily know that that's true. And so I want to segregate them. Likewise, I might have PCI versus non-PCI compliance, where I just simply have different requirements from an auditing perspective on what's needed to assert trust and to guarantee trust. So I might have one trust domain for, say, PCI.acme.com versus other things. And so there's these sort of trust domains, and then under a trust domain is this thing called a workload identifier that just kind of looks like a path, really. And in fact, as far as SPIFFE is concerned, it doesn't even have to be a path. It's just an opaque string. The path semantics are just there for convenience. And SPIFFE doesn't actually reason about any hierarchy with these things. It's really up to the implementation what kind of hierarchy they want to create, and how they want to structure these things. And in fact, we don't really reason or dictate to folks how they want to do that. It really depends on what they want to use SPIFFE IDs for, and to come up with a sort of naming scheme that makes sense there. But that's the string, the identifier. Once you have the identifier, then you then need a way of having a provable version of that identifier that you can use to assert this identity, or rather assert, if I hold this document, it should allow me to assert that I am entitled to this identity. And the SPIFFE specification reasons about that as well. It calls this broad class of documents that can be used to assert identity SVIDs. And we actually have a couple of different types that can be used in different applications. So the one type is based on, which is typically used for, say, establishing a TLS connection, is based on the X509 certificate format and the PEM keys, and that's called the X509-SVID. So it's basically a key and a certificate that's delivered to the workload, as well as a trust bundle, or a trust bundle that represents the certificate chain that can be used to validate that key and certificate by a remote workload. And what SPIFFE is able to do is, when it identifies something, it's able to give it a typically short-lived certificate along with an associated key, and then that can be then used by that workload to, e.g., establish a TLS connection to a remote workload. The remote workload can then check the trust bundle to verify that the certificate key are actually valid. There's other forms of this document too, though, that are also made available by the workload API. The other one that's been actually implemented is the JOT standard. So the API has semantics to be able to retrieve a JOT token, again short-lived, and again scoped, that the workload can then present, say, an HTTP request to another workload, and then there's also semantics in the API to be able to validate that JOT. And so that's kind of more of a and these two are actually kind of nice complements to each other. One of them is asymmetric, which has a lot of advantages. The other one is basically just a bearer token for you, but a short-lived one. All of these are retrieved via an API that I'll come to in a second, which means that it's actually quite easy to automate the generation and creation of these documents from a workload's perspective. But this also encodes but basically what the SVID spec reasons about is it takes, for the most part, existing document types like X509 and JOT, and then basically add some additional constraints to them to say, this is how you encode a SPIFFE ID in a JOT, or this is how you encode a SPIFFE ID in an X509 certificate. Yeah, so that's the SVID, and then the final part of the specification we can talk about today is the workload API, this API that a workload uses to actually get these documents so it can start establishing connections and or verifying connections. So we call it the workload API, I can point you folks to the protobufs or other documentation to kind of go through the spec in detail. But I'll confess it's been a little while since I've looked at it myself. But the key piece really of this workload API is that it doesn't need any existing authentication in order to call into it. You basically, you call into it without any credentials, and it's the responsibility of whatever infrastructure is implementing that API to figure out which workload it's talking to and to issue it its documents. And that probably sounds a little vague, so I can give folks a more useful overview with. I can give you sort of a more concrete example when we talk about how Spire works. So cool. Before I move on, folks, does that make sense so far? Any questions about the kind of SPIFFE specs that I can help with?
Is there a common understanding of what a workload is?
Yeah, it's a great question. So it's pretty generic. We, concretely, when we talk about a workload, we're really talking about a process running on a machine somewhere. Now that said, actually, maybe I can give some concrete examples. Might be a little bit better. So, concretely, a workload is a process running on a machine, but it's not necessarily identified at a level that's that granular. So, a workload. So the thing calling into the API is a process on a machine somewhere. But the identity that it gets back will usually be more general than to a specific process on a specific machine. It'll usually be, say, an application or a service or something like that. And the way that it's described is usually in more general terms. So in a second, I'll talk about attestation policies that'll make this hopefully a little bit kind of more concrete and clear. But yeah, there's a range of different ways you can actually describe these things. So yeah, actually, maybe if I jump into Spire, that might sort of, as an indirect way, kind of answer some of these questions. So if I do that, so as I say, SPIFFE is the sort of specs. Spire is a set of piece of software that you actually run, and there's two components to it. There's two broad components to Spire: the server and the agent. The server can run anywhere you like. And it can run on a VM, or it can run as part of a Kubernetes cluster. The server is effectively a combination of two things. It's, as I say, and we'll come back to how these work in a sec, but basically there's a certificate authority, a registry of workload identities and policies. We talk about this word policy a lot, and I'm curious as to whether or not this group actually likes that terminology, but we have a set of policies that define basically the conditions under which those identities should be issued. So this is a really kind of simple example of what an attestation policy might look like. Basically, what metadata might be stored inside a SPIFFE server. Concretely, there's a SPIFFE ID, an identifier, and then these set of selectors that form this attestation policy. And so these are basically the conditions that need to be provably met in order for some piece of software to be granted this identity and be granted an SVID to prove that identity. And so in this sort of contrived example, what we're suggesting is, we're saying the selectors say two things. One is that this workload needs to be running on an EC2 instance in Amazon Web Services that has been proven to be a member of this security group. And then we're also saying that on the instance itself, it needs to be running as a Unix process, and that Unix process needs to be running under this UID 1001. This attestation language, though, and the set of selectors you can use is extremely flexible, and again, that's kind of by design. So, as you might imagine, for different cloud platforms, there's different selectors. If I'm running on Kubernetes, for example, there's Kubernetes-specific selectors, so I can describe workloads, say, in terms of a Kubernetes namespace or service account, for instance, rather than Unix constructs like these. But the general idea is that there's these set of selectors that together kind of platform, what we call an attestation policy. And this policy is not in itself really an access policy in any way. It's rather the set of conditions that need to be met in order to grant an identity to something. And that's actually sort of a more general point I should probably make about SPIFFE in general. SPIFFE is just reasoning about identity, or you could say it's reasoning about authentication. It doesn't in it, and it's designed as a system and as a framework is really designed to help things establish trust to each other. And for me as a workload to know what other workloads I'm talking to. It doesn't reason at all about authorization. So having established trust and knowing now that I'm talking to some other system, SPIFFE will not help you reason about whether you should actually be allowed to talk to some other system. It's sort of by design that we've tried to keep that out of scope. There's a bunch of other technologies like OPA, for example, that obviously do reason about that and provide kind of policy effectors for access control. And we see these kinds of things as really kind of nice complements, right? If you have a strong sense of identity, then you can do authentication, and then on the basis of that, you can start to do robust authorization. And I bring all of this up because when we talk about policy here, again, it's very much about just being the policy by which something should be identified, not the policy by which something should actually be allowed to access something else. Although obviously the former is to a certain extent kind of a component of the latter. Does that all make sense, by the way? Does that sort of broadly pass? Kind of approaching 4:30 in the afternoon here, I tend to ramble a bit, so I make sure.
Yeah.
Cool. Cool. So that's so the SPI server kind of contains this registry of metadata, and there's usually thousands of these things. Bear with me. So then we also have to actually for a day in the life of an SVID of a workload's actual identity, we need to figure out a way to identify something. And as I say, we have this challenge because we've made this assumption that the workload itself shouldn't have to hold any kind of bootstrap credential or anything else that it needs in order to prove itself, because that would kind of defeat the purpose of SPIFFE if I had some like master API key or something like that I needed to pass into Aspire to prove who I am. So we want to be able to do this entirely out of band. So the way Aspire does this is with an agent, and the agent runs on effectively every kernel that is running workloads that need to be Spire identified. So you run on these on every EC2 instance that these have SPIFFE identities. If you're running it in Kubernetes, you would run one of these on every node in the Kubernetes cluster. Like you run it as a daemon set or as an actual daemon if you want. This thing runs local to the node, and it exposes the workload API. On Unix, it actually does this over a Unix domain socket, and that turns out to be a really important property. The workload later, when it calls into the workload API, calls over a Unix domain socket, and the Spire agent can use that to then interrogate the kernel to figure out metadata about the workload itself, and things like UID and PID and so forth. But before all of that happens, the first thing that needs to happen is the agent running on the node needs to authenticate itself back to the Spire server. And this is where, and Spire is actually very flexible in terms of the different authentication strategies that it supports between agents and servers. When it's in this kind of contrived example, we have an agent that's running on an EC2 instance. So we use an EC2. We use what we call an attestation strategy, basically an authentication strategy that leans on actually leans on the AWS instance metadata API. The Spire agent will retrieve an instance identity document, and then it'll pass that to the Spire server. Spire server will then verify that with Amazon's public key, and then use that to retrieve the instance ID. And then it can go back and talk to Amazon and pull in a bunch of other metadata about the machine as well. So things like what security groups it's in, what labels and tags it has, etc. And from that, it'll build up a profile of the thing it's talking to. And so then it'll, having done that and authenticated the agent, it will then look at its list of attestation policies and see if there's any attestation policies that this agent needs to know about. And if it does, if it can find them, then it'll pass basically that list of SPIFFE IDs back that could conceivably be allowed to run on this node, as well as the remaining parts of the attestation policy that the agent needs to know about. So at this point now, we've been able to establish trust to the instance by leaning on Amazon. So we know which instance we're talking to, and we then, but we don't really know anything about the workloads running on that instance at this point. And so now the agent has this list of the workloads that can conceivably run on it and the conditions under which they should be granted an identity. So now the workload wakes up and it wants to retrieve its identity. So it makes this call over a Unix domain socket to the workload API and just says, hey, I'm here, tell me who I am. And so the Spire agent's responsible. What the workload API needs to do is respond with an ID and then also with a short-lived SPIFFE. So to get to that point, the first thing that the Spire agent does is, because it's a Unix domain socket, it can check out of band to see what it can check with the Linux kernel, basically to say, tell me about this thing that's running on my machine. And so the kernel will say, yep, this is a process, it's PID blah, UID blah, GID blah. We've also got this process is also pluggable and can be extended in a much different way. So for example, if this thing is configured to be running, identify workloads running in Kubernetes, what the Spire agent can then do is then also go and talk to the local kubelet and say, hey, kubelet, the kernel, this thing's calling me, the kernel's told me it's got PID 2007. Can you tell me anything about this workload? Does this represent something that you've scheduled as part of a pod? And if it is, can you give me some of the pod spec metadata about this as well? So the Spire agent compiles, just as the Spire server did for the agent. The agent now for the workload compiles this list of attributes of the workload that it trusts to be true because the kernel and other trusted third parties like the kubelet have told it that it is. And then it compares it to this list of local attestation policies that it has. And hopefully there's a match, right? Hopefully that this workload, for example, is running under that user ID that we mentioned before. And if there is a match, then the agent goes, great. I now have an identity I want to give you. So before it does that, though, it needs to generate a key for that workload. So it generates the private key. This private key, by the way, never leaves the machine. It generates the key, and then it'll send a certificate signing request back to the Spire server to get a certificate. And then that certificate will be signed by the Spire server by the signing key of that Spire server, which is also the signing key bound to that trust domain that we talked about before. And then the certificate gets passed back to the Spire agent over this authenticated channel that we previously established. And then the Spire agent will deliver both the key and the certificate, and in fact just the identity as a string up to the workload, along with a specified TTL. Say, this is valid for this amount of time. And that's another point I should point out, is that it's configurable how long this TTL is, but typically you'd expect this certificate to be reasonably short-lived, certainly no more than an hour, and it can certainly be less in many cases. And so then the workload can now use this key. This is the X509 SPIFFE that we talked to, sorry, key and certificate. This is the X509 SPIFFE that we talked to say establish a TLS connection to something else. With JOT, it's a similar mechanism. And then what the workload also gets is it can query to get the certificate trust bundle if it wants to verify the key and certificate of any other workload that it should know about. And then this is just sort of a sort of slightly more contrived example talking about how this works. And just to point out that, again, this attestation framework is actually pretty flexible, and the language is actually pretty flexible. So we can talk about, say, identifying workloads running in a Kubernetes cluster with a particular image SHA, service account, and namespace. And that's kind of about it. The only other thing I sort of wanted to bring up was kind of the ecosystem that's getting built up around this. So we really see two. There's the ecosystem that exists above SPIFFE and systems that are becoming SPIFFE compatible. And so there's a few different proxies, a few different secret stores, a couple of different libraries. gRPC support is in the works right now, for example. Different systems that can basically just can lean into this API to automatically retrieve their bootstrap identity credential. And then we see a bunch of different systems implementing this over time, including Spire, but also others as well. Within Spire, Spire itself is very flexible, so there's a bunch of different extension points that folks can contribute to if they see necessary, whether that's different attestation strategies for identifying workloads in different environments, different integrations into trusted third parties like, say, HSMs, TPMs, And then there's also, just different sort of back-end storage strategies for persisting data and for persisting keys and for storing and signing, signing interfaces and things like that. So there's a pretty rich array of extension points there. But yeah, that's kind of about it. That's SPIFFE in a nutshell. It's a framework for trying to figure out what a software system is and giving it an identity so it can go prove that out to other software systems. Yeah, that's it.
So is still using SPIFFE spec, right?
It's using bits of the SPIFFE spec. So when they started, the SPIFFE spec is still a slight moving target, although it's a lot more robust now than it was even a year ago. They are implementing the SPIFFE ID and the SVID part of the spec. They haven't implemented the workload API yet. And so in other words, the workloads inside Istio, I believe, through a different mechanism than the workload API, it might just be as a secret inside Kubernetes, can retrieve a short-lived SVID that will identify them. So an X509 certificate, basically. And Istio uses its own mechanism to figure out what the identity of a workload should be.
Having dealt with certificate management, that definitely seems to, it pushes down to secrets and cert management issues. Has that complexity been a problem, or?
I think it's actually I guess the one way of looking at what SPIFFE and Spire, what Spire in particular is trying to achieve is, in some ways, it's trying to allow you to establish, best practice turnkey PKI by making a few assumptions, of course, but without a lot of the complexity that's necessary there. So there's definitely a lot of challenges that were involved in developing Spire to kind of manage these keys efficiently, to handle the rotation efficiently, and to sort of expose the right API semantics that make sense and support kind of other applications on top of that. But yeah, I guess the idea really is to try and make sure that these things get encoded in software and are standardized through APIs, so that the mechanics can be something that regular folks don't have to deal with. They just implement it and it works. And for the most part, I think that's been true. You definitely get into interesting cases when people say, for example, have their own, say, like, we have a thycotic implementation, and that's where our master keys will sit. That's the only solution the security team is going to accept. So I want this, but I want it to use thycotic as the signing, basis for signing.
Yep.
So there's definitely cases there where things have gotten interesting. We've tried to design Spire with a lot of those use cases in mind. So in that particular case, for example, we have a sort of extensible plugin where you can call out to a third-party signing service. You could actually hook this into Acme as well, or other systems if you really, Let's Encrypt if you really wanted to in other cases as well. So there's a bunch of interesting things you could do with that. But yeah, generally things like that come up, but for the most part, things have been fairly straightforward.
So how did the more kind of somewhat of a structure, the idea of attestation policies come into being with it? In some ways, you could just totally leave that up to the implementations, right?
Yeah, so the attestation policy is not actually part of the SPIFFE spec at all. That's just a construct within Spire.
Okay.
Yeah, and it came up with Inspire because we wanted Spire to be flexible and work in a range of different environments. So we didn't want something that would, required you to have, say, Kubernetes constructs in your environment to reason about, or required you to have, say, Amazon constructs to reason about. We wanted to support. It's not the only model that works, though. One thing we've talked about is having, federation between different SPIFFE issuing authorities, if you will. So that might be multiple Spire implementations, but it might also be, say, Istio Citadel and Spire, or two different Istio Citadel implementations. And so the idea there is that maybe, in this case, or maybe even a cloud platform provider, right? Like maybe Amazon could become a SPIFFE identity provider. And so then in that case, the cloud whatever mechanism, whatever the implemented the implementer can do whatever the implementer needs to do in order to make its identity assertions, and you just need to trust that that's valid. And if you do, then it's fine. And in the case of, say, Citadel, for example, it can say, well, look, we in turn know we're running on top of Kubernetes. We're going to trust Kubernetes, and so we're going to lean on that. But it's and then it can just be a sort of exercise for the reader to decide if they want to use that implementation for identity or something else.
So does that mean Citadel also have the attestation policy similar to Spire, or?
So I think that's a great question for the Citadel team, actually. So it doesn't have to. So Citadel, in fact, Citadel today does not have this idea of an attestation policy. I think I'll let definitely better experts than me on this, but I believe the way Citadel works today is that basically it issues identities based on Kubernetes service accounts. So there's kind of it'll just say, okay, for whatever workload's calling me, I assume we're running in Kubernetes. I'm going to find out whatever service account is associated with this workload and generate an identity on the basis of that.
Okay.
I think they're moving to a more, I've seen design docs that suggest a more flexible model. It looks a lot more like Spire, though. And that in turn does require Spire-like an attestation policy in much the same way Spire does. But again, however Citadel does it or however Spire does it, it's an implementation-specific detail. In the case of Spire, then it has this attestation framework, and so the policy reflects that. Spire might use very different semantics for conferring identity.
Okay.
Yeah.
Another question is the like the SVID extendable? For example, you mentioned there's the concept of trust domain, right?
Mm-hmm.
You can identify which trust domain your workload belongs to. So now, say, if we want to introduce the concept like, for example, policy domain, because there can be different policy regimes for, or even across different trust domains, right? So is it possible to add another top level domain that could help federation or cross cluster, cross domain stuff?
Maybe. So we've up until now we've kept SVIDs pretty constrained in terms of what they're able to represent, and we need to be careful as well. I think because with policy decisions, sometimes things can be workloads can be dynamic in terms of. So SVIDs SVIDs have a lifetime to them, but they're static across that lifetime. Whereas a lot of policy attributes can be quite dynamic. So we want to make sure that we're not kind of conflating things there. One thing that has come up is with say with Spire, for example, before I give something its SVID, its identity, I need to have checked certain assertions against that workload, right? And in the case of Spire, it's going back to its attestation policy and checking elements of that policy to see if it should be giving this identity to that workload. So it's probably reasonable to include that metadata in the SVID. So, for example, if I've had to check that this workload is running in the security group and it's running under this user ID, to in the SVID along with the actual workload ID string itself to embed those assertions that security, that this thing is, we've checked this thing's in the security group and we checked this thing has this user ID, and embed that in the SVID as well. And then when the workload's making a claim, it can make a claim about those attributes as well as a claim about its own identity. But so far we haven't done that, and the way customers have gone and solved for that is they've just taken the SVID ID. If I'm a remote workload and I want to check part of it, I want to check, say, Spire attestation policy against that, I take that workload ID and then I just call Spire directly and say, hey, Spire, can you tell me about this ID?
Okay, that makes sense. Yes.
Yeah, there's some work as well. If we wanted to sort of put that stuff into the SPIFFE spec, then we need to figure out a sort of vendor-neutral way of describing assertions. And
yeah, I was going to ask. There's been the Grapheus project, which has somewhat attempted to have a standardized attestation API. I don't think there's been a lot of momentum to get it somewhere. I don't know.
Oh, interesting. I didn't. That's interesting. So what kind of assertions does Grapheus make for now?
I can find it for you. One of those Greek words that
Oh, totally.
I think their original sort of use case is, yeah, more supply chain, like signatures on your images, or
Gotcha.
verifying it doesn't have any CVEs, that sort of thing.
Gotcha. Yeah.
Which
Yeah, that actually, I mean, it'll be interesting to. I mean, yeah, I'm curious if there is momentum there, if there's some language that can be repurposed.
Yeah, it could be. I also because there's kind of two models a little bit. There's sort of the dynamic part of the workload, right, where it needs to kind of have it's an instantiated identity once it starts running in a specific context. And then there's I don't know if it's the supply chain, what the bits are and how they come together and verifying that. That makes sense.
It's I think the way we've looked, I don't know if this is valid, but the way we've looked at it is to say, you know, where supply chain, like there's a lot of work on supply chain in terms of, you know, being able to assert the provenance of something and, you know, metadata based on that provenance, but not a lot around actual enforcement. And so one thing you can actually do with Spire is, I know somewhere there's a tough plugin, for example, there's a tough workload attester, and that allows you to add to your attestation policy something saying, for example, verify that amongst all the other things, all the other attributes of this workload, verify that this thing has actually been signed by this public, you know, this public key before issuing it. So the only assertion that Spire is making at that point is that it has actually been, you know, that it came from the, you know, it's been signed by Tough and therefore presumably came from this source. But then there's a bunch of transient assertions you can make because of that. Transitive assertions that you can make because of that, which would be kind of interesting.
One thing if the workload asks for its own identity, right, it has to start running to do that, as opposed to, I imagine, like when you're trying to verify that an image has been signed, it's your image. Starting it up at all, the assertions kind of come first. There've been, at least in implementations, talk about reversing or the order of running the thing and getting an identity for it.
Yeah, I mean, I think that's so that's a fair point. With this, so basically in this model, a workload, you know, like a malicious workload could run perfectly easily, as long as it doesn't call the workload API. So the question then becomes, you know, can that malicious workload do any damage without an identity? You know, can it assert itself? And if there's damage it can do without an identity, then this isn't much of a gateway. If you wanted to check the identity of a workload before allowing it to do more, then that does become a little trickier. But you could say, for example, have like init containers that would perform that check, and would require, you know, in a Kubernetes context, for example, you might use an init container to validate that, or some other property.
Build it into the runtime or something.
Yeah. Or like an admission controller that, actually you can do, I guess you can do things like an admission controller that just operates totally outside of SPIFFE and Spire altogether. But yeah, Spire's really only in a position, or SPIFFE, I guess, as well, is really in a position to allow a thing to get its identity or not. It's not really in a position to make deeper
judgments. There was something I was thinking. Have you gotten Amazon or anyone else to play nice and maybe start standardizing?
Not so much right now. It's kind of early days. I think we're starting to get kind of a little more interest on the vendor side. No major cloud platforms as yet, but you know, some interesting conversations with HashiCorp. We're starting to have conversations with the Istio team. But it's been kind of slow going, and it gets pretty political, as you can imagine. The more interesting space, I think, the more fertile ground, I think, for us right now is seeing more momentum in consumers of the API rather than producers. And our hope is that if the latter would then drive the former. So you know, we'd so gRPC, for example, would be a big win. You know, seeing products like, say, Prometheus and, you know, Fluentd and other kind of other systems that are already distributed kind of just have an option to lean on SPIFFE directly. Database products, for example, particularly ones that already support X509 authentication, to the extent they can kind of lean on SPIFFE. I think the more momentum we see around our strategy right now, if you will, is just to say if we can drive more of an ecosystem there, then that means that for increasing number of customers, it'll just make more sense if the platform can just provide SPIFFE IDs natively, and at that point we get more interested in the standard.
Does the current implementation for Kubernetes, the agents, does that require running privileged workloads at all?
Yes, it's privileged, and I'm at the edge of my expertise on this, unfortunately, but it needs to be privileged enough that so it runs as the agent runs as a daemon set, and
Right.
it needs to be able to expose a Unix domain socket to other workloads running on the same node. Sorry, other ones running on the same node.
Do you know if the workloads have to have a certain level of privilege?
Oh, right. I don't believe so.
Okay.
Yeah. I may stand corrected on that, but I don't think so.
I mean, that's usually one of the first no-goes, at least in OpenShift, of when it's well, I have to wait for something else.
Yeah.
But,
yeah, and as long as the workload can call that Unix domain socket, that's really all it needs to do.
yeah, Prometheus is actually an interesting case because you have all of the metrics on the nodes and for the workloads. So it's kind of an attached workload that then, communicate with the Prometheus server. And so all of those things have to get their certs set up, and it's a pain to do automatically.
Oh, totally. Yeah. And it's, I think as well, an interesting case here, right, is you start to, there's a couple of interesting cases that we haven't explored too much, but would be really cool to see more people play with. One of them is, just bootstrapping the PKI of a bunch of these other systems, right? So whether that's Kubernetes itself, whether that's something like Prometheus, and then PKI between clients and servers. And then actually as well, when it comes to metrics, once you have a kind of common workload identifier that everything understands and say, hey, we can correlate machine level metrics to workload level metrics to, cluster level metrics. We can actually die trace that stuff too. There's an interesting demo a colleague of ours, Sabri, gave at OSCON recently, where they kind of tried to show this off, right? So it allowed you to sort of take things from Jaeger traces that had SPIFFE ID, the SPIFFE ID asserted in it, and then be able to map that to Prometheus metrics. And really all it was just making sure everything was keyed on the right thing and making sure the data was encrypted with that key. But it was a neat example of just being able to know that once you know the workload identity and you know what it's bound to, you can then correlate that with other metrics and get a lot more interesting kind of pathology reports.
Do you see a world where there's multiple identity registries beyond, or I guess right now it's more focused you're probably running on one platform and you can get one ID for that.
Mm-hmm. I think we kind of look at this as do you mean multiple registries in that I'm a workload and I need to talk to a bunch of different systems and I need to present different identities to those different systems because that's
one possibility. Yeah. The other is if those identities are still understood across different systems, if you have more than one option of how to get that. Oh,
right. Yeah. So I think the way we look at this, because that to me is I think the way we look at this is kind of a secrets management problem, right? I have a workload and I have a single kind of primary identity, if you will, but then I also have I need to go and talk to AWS so I can talk to the S3 API, or I need to go and talk to Twilio, and I need a credential for that. And so there's then this okay, well, how do I generate those? How do I store them? How do I map them to this primary thing? And that's definitely something where secrets management becomes great. So something like Vault, for example, is kind of an interesting solution. How I think SPIFFE fits into that is rather than solves for all that. The problem with something like Vault, of course, is it's that what is that bootstrap credential, right? How do I authenticate to Vault in order to be able to get all of these derivative identities? And that's something where SPIFFE can fit in really nicely. In fact, there's kind of a nice integration story now that Vault's moved to Go 110. There's actually a nice integration story with Spire deploy. If you give everything SPIFFE IDs, then it's pretty trivial to map that to policies in Vault and to have Vault be able to trust those identities. And that basically what that means is as a workload, I call into the workload API, I get my SPIFFE, I then take my SPIFFE and use that with the to authenticate to Vault, and then from Vault I can pull out all my other identities, and I can start using that with whatever other system I need. So SPIFFE in itself doesn't reason about that, but it gives you this really nice building block to build other systems on top of it to do that. And on the commercial side, for Sitel, the company, that's definitely something that's been a lot of energy on.
Yeah. Interesting. Yeah, one of the interesting models is like the capabilities access control model. You're familiar with that a little bit?
Not really, no.
As sort of where, I guess if I look a bit the actual definition, it's kind of mixing the authorization with the identity. So if you have a reference to something, that reference is also contained the access controls.
Oh, right. So would like an OAuth access token be an example of that?
I think more like the S3 URLs that you can specifically give to people. I guess there's whole operating systems that have more complicated things.
Gotcha. Interesting. It's so there's actually like one thing that inspired a lot of SPIFFE's design was the Netflix team. So Netflix have a system called Metatron, which is conceptually very similar. They're actually thinking about rebasing that on top of SPIFFE, so it's same infrastructure but just different construct identities. But anyway, that definitely inspired a lot of what SPIFFE was doing, and one of the key things they did, so they wanted distributed authentication and authorization. And they very explicitly said, we're going to build systems to do each of these things, but we're going to very explicitly decouple them. And the idea behind that was because, I guess, to enforce an authorization decision, you need an effector, like maybe it's a library or a proxy or something like that, that's actually going to decide, do we allow this thing to happen? And that in turn will need identity asserted of whatever's calling me, and then it'll also need to be able to call in and make an authorization decision. And they said, we see a world where like this is happening in a bunch of different contexts, right? Like maybe it's a HTTP request and it's a proxy making this call, but maybe it's also like a worker pulling stuff off a queue and verifying the provenance of the queue job and then deciding if it wants to go work on it. Or maybe it's like a streaming protocol of some kind. So there's a bunch of different cases, and it becomes actually quite difficult to confer attribute and access at the same time in that model. So it's better to have a separation. And so what they do is they have Metatron exposing, the sort of moral equivalent of the SPIFFE workload API for identity. And then they also have OPA as their, policy API basically. And then a bunch of different things lean on that.
Yeah, I was talking with them a little bit about that. I guess they've got it pretty fast now, the policy. What is it? Computing it. Or enforcement points.
Totally.
Yeah. Because that's definitely something that okay, that's interesting. Yeah, the complexity blows up basically as you start. I could see maybe there's differences between when it's like one company and you have a bunch of interconnecting and talking things versus like a bunch of third-party things, such as like on your phone when you have a bunch of apps that never really should interact with each. So
yeah, totally. And it's, I guess, OAuth has done a pretty good job of this too, right? And so when I have an OAuth access token, that confers my identity, and it also confers, it confers my identity with respect to you, and then there's a specific set of things I can do with that, which is useful. But yeah, it's nice also, right? Because that bearer token that I'm using is suitably constrained as well. That access token is of limited use if an attacker gets it. But the flip side is there's a lot of context embedded in that kind of authorization logic, I guess.
Yeah. OAuth was designed for the web and browsers, and,
Right.
and it's interesting that we're kind of taking certain things from it at work, but sometimes it's still a little bit iffy.
Yeah, and it's, there's a lot of different flavors of OAuth, the different types of application, which is sort of, I guess, sort of a consequence of the fact that they've got this very kind of strongly typed model for, anyway, yeah.
Oh, that actually would be kind of cool. What's the, like, if you even attached it to your browser, that'd be kind of fun. That's more like a hackathon thing.
Yeah,
SPIFFE
totally.
IDs for your web
Well, one interesting
sessions.
like version of one thing that this could be useful for, right, is if you wanted to build sort of beyond corp type infrastructure, where typically like I create, to authenticate, I need something that asserts both the machine I'm running on as well as your user. You could use something like this either as the basis of that, right? You could say, hey, like I'll use SPIFFE to figure out the right machine is effectively what it should be. Like this is Erica's laptop. And also that I've checked that it's Erica's laptop, right? Like maybe I've gone to a HSM and gotten a token, or I've checked the key that you've got on the side or something like that. And then use that with something like LDAP to figure out if it's should be authorized or not.
Yeah, I've been talking a lot. Howard, do you have questions?
No, I've got everything I want to know.
Cool. So unfortunately I have to run. I've got to go pick my daughter up. But
yeah, no problem. Thank you so much.
No worries.
Yeah,
Hope it was useful. Feel free to shoot me questions as well. I think you should both have my email.
Okay.
Cool. Awesome. Thank you for joining.
No worries. Take care, guys.
All right. Happy New Year.
You too. Happy Year of the Pig, everyone.
Bye.
Bye-bye.